Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 15.1 probability. We start with problem 1. Complete the following statements. First one is probability of an event E plus probability of the event not E is equal to 1. Because as we all know, that is probability of, for example, probability of getting a head and probability of not getting a head in tossing a coin is always equal to 1, right? Not only in this case, just for an example, here I have taken a coin. So whenever a coin is tossed, what are all the possible outcomes? We will be having head or tail. So probability totally we have two outcomes. Out of two, what is the probability of having a head? Only 1. So it is 1 by 2. And probability of not having a head, what does this means? Not head means probability of getting a tail. So here it is again 1 by 2. So when you add 1 by 2 plus 1 by 2, they will make 1. Okay, not only for this case, for whatever may be the type of problem, probability of doing an event plus probability of not doing an event is always equal to 1. Or example, probability of getting something, okay, and plus probability of not getting is equal to 1, right? Now the second question is the probability of an event that cannot happen is 0 and such an event is called impossible event. So here we will take this example. So whenever a dice is thrown, whenever a die is thrown, what are all the possible outcomes we have? We have numbers from 1 to 6. Right. So if for an example, probability of getting number 7 if a die is thrown, is it possible? In a die, there is only chance of getting numbers from 1 to 6, okay? But the probability of getting number 7 on a die is 0 because it cannot happen. So that type of event is known as impossible event and the probability of an event that cannot happen is always 0. Right. Now the next thing is, you see the probability of an event that is certain to happen, that will happen is, then it is 1 and such an event is called sure event or certain event. So here in this case again we can consider the same example of throwing a die. Here probability of getting odd numbers, probability of getting even numbers. So it is possible with these options, right? So that type of event is known as sure event or certain event. Then the next question is the sum of the probabilities of all the elementary events of an experiment. So what is meant by elementary events? That is whenever an event has equally likely outputs. For example, again we can consider an example of tossing a coin, right? So whenever a coin is tossed, we will be having either head or tail as the output. So probability of getting a head is 1 by 2 and again for the tail it is 1 by 2. So these type of events are known as elementary events. So the sum of probabilities of these events are always equal to 1. Now the fifth question, the probability of an event is greater than or equal to 0 and less than or equal to 1 because the probability range it lies between 0 to 1. Right. So it should be greater than 0. It can be greater than or equal to 0 and it is less than or equal to 1. Second question, which of the following experiments have equally likely outcomes? Explain. So the first one is a driver attempts to start a car. The car starts or does not start. So here, if the car is in good condition, it will start. If car has some fault within it, okay, some engine fault or if the tire get punctured, whatever may be, the car won't start, right? So here we have many reasons for a car that does not start. Therefore, here this event is not equally likely, that is this event doesn't have equally likely outcomes. So this is wrong. Okay. This event is not an equally likely outcome event. Now the next question is, a player attempts to shoot a basketball. He or she shoots or misses the shot. So again, when a player is well trained, or if a player has a good experience in shooting, then he will shoot. Okay. But if the player is new, or he doesn't have enough experience or enough training, then he will miss the shot. So again, we have many reasons for these things. Again, this event is not an equally likely event. Now we will proceed with the third one. A trial is made to answer a true-false question. The answer is right or wrong. So actually this is a true or false question. So either you have to select right or you have to select wrong. Right. So this event is said to be an equally likely outcome event. Now the last one. A baby is born, it is a boy or a girl. So obviously when a baby is born, we have only two genders to go with. Either it may be a girl or it may be a boy. So again, here this statement has equally likely outcome. Right. Now we will proceed with our third question. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So again, what do you mean by tossing a coin? So again, we will start from first. Whenever a coin is tossed, what are all the possible outcomes? We will be having either a head or a tail. Right. So the probability of getting a head is given by, that is totally we have two outcomes. So probability of getting a head is 1 by 2, because among these two we will be having 1 because we have only one head. Again, probability of getting a tail is, out of two outcomes we have only one tail. So again it is 1 by 2. So this is what is it? Tossing a coin is considered to be a good way of deciding which team should get the ball. Right. This is the reason why we, even in cricket also, why tossing the coin is considered as a good thing. Now, our fourth question is, which of the following cannot be the probability of an event? So here, we know the range of probability, right? So the probability is, it always lies between 0 to 1. So here, when you solve 2 by 3, again you will be getting answer in the form of point. Here there will be 20, right? So 0.6 something. So this lies in the range of 0 to 1. And here the next thing is, we have a negative term. In probability there is no negative terms. Right. So this is not possible. Again here, even the probability can be expressed in terms of percentage, because again when you solve 15 by 100 will give you 0.15 as answer. Again it lies in this range. Now 0.7, obviously it lies between 0 to 1. Therefore here this option B, that is minus 1.5, is wrong. Okay. This cannot be the probability of an event. Now we will move with our last question, problem number 5. You see, if probability of E is 0.05, what is the probability of not E? We know, right? Probability of an event and probability of a not an event, that is equal to always 1. Here probability of E plus probability of not E is equal to 1. We are given with probability of E. So just substitute it here. Then you can easily find a probability of not E. So you see, this is what I had done. So 1 minus 0.05 gives 0.95. So this is the probability of not E. So that's all. If you have any doubt, let me know in the comment section. Thank you.